Proceed straight.
Well, we're 0 for 6. Last chance is the Elmhurst Country Club. Other side of the lake on the southeast side.
I don't get it. I really don't get it. I thought this would work. Threw everything I had at that guy, nothing.
That's how it goes sometimes, you know? You lose everything, and everything falls apart, and eventually you die and no one remembers you.
That is a very good point, Dwight.
Make a right turn.
Wait. No. It means bear right.
No,
Up there.
It said right. It said take a right.
No, look. It means go up to the right, bear right, over the bridge, and hook up with 307.
Make a right
Maybe it's
turn.
a shortcut, Dwight. It said go to the right.
It can't mean that. There's a lake there.
I think it knows
where it is going.
This is
the machine knows.
This is the lake.
Stop yelling at me.
No, it's
Stop
up
yelling.
there. There's no road
Here. Remain calm. I have trained for this. Okay. Exit the window. Here we go.
Make a U-turn, if possible.
Look out for Legion. Michael, are you okay? Swim for it. I got you. Michael. Let go. Let go of Michael. Come on. I got you. Michael, come on. Go on.
Good morning, I'm Captain Stitt, one of the land navigation primary instructors here at the basic school, and this period of instruction is Military Topographic Maps 1. The purpose of this class is to develop your baseline knowledge of how to read and interpret your maps, as well as introduce you to the military grid reference system. The reason I play that clip from The Office is to emphasize the importance of developing your land navigation skills in light of available technology. While the Marine Corps utilizes numerous advanced navigation-related technologies, that technology is not infallible. Enemy interference such as an electromagnetic pulse or natural phenomena such as a solar flare can significantly degrade that equipment or render it inoperable. As a Marine Corps officer and leader, it is your responsibility to retain the land navigation skills you learn at the basic school, train your Marines to the same standard, and apply those skills with confidence when technology fails. So, what is the actual goal of land navigation at the basic school? This is your land navigation terminal learning objective. The goal is to enable you to accomplish this objective in any area of operations in the world. How do we train to and evaluate this skill at the basic school? Well, we send you alone and unafraid into the Quantico tree line in search of these. The infamous red ammo can. For some of you, land nav will be an emotional event, but in order to ensure you gain mastery over this skill, you will receive up to 6 hours of platform instruction and over 40 hours of land nav practical application. That's not including the time spent applying your land navigation skills during field exercises. So now that you have a better understanding of why we teach land nav at the basic school, let's take a look at the agenda for this class. First, I'll be covering the broad scope purpose of land navigation as it relates to military operations. Then I'll provide you with an introduction to the land navigation package at the basic school, including an overview and schema maneuver for each event, required equipment, and some enduring rules and restrictions. Then I'll dive into the meat and potatoes of the class content. When discussing the purpose of land navigation and the use of maps as it relates to military operations, General George Washington speaks to the importance of acquiring and utilizing accurate maps to gain the advantage in battle in this quote. And whether it was the use of field sketches in the Revolutionary War and Civil War to leverage advantageous terrain, or the use of cartography during World War I to place accurate artillery rounds on target, military commanders have been utilizing maps to gain the advantage in battle throughout history. Now, in order to fully harness that advantage, the commander must study and practice these skills. Now let's take a look at how we accomplish this at the basic school. This is a breakdown of your land navigation package by event. Your first event will be the Land Nav Prac app, where you will develop your land navigation strategy and techniques in a group setting led by an instructor or SPC. From that point on, you will execute your practical application events independently, culminating in Final Land Nav Day and Final Land Nav Night. These are the only 2 weighted events in the package. Now let's review the skimming maneuver for each event. Keep in mind, this skimming maneuver remains enduring for the entire land navigation package. Land navigation reps from each platoon will submit their platoon rosters to the primary instructor for that day. Primary instructor will then hand out route cards, conduct a safety brief, and provide you with at least 30 minutes to conduct your map work at the command post, whether that's a classroom or an LZ near your training area. You'll then be required to sign out on your platoon rosters prior to executing that event. That way we can track you in the tree line. Finally, upon execution of your route card, you'll turn it in to the command post to be graded by either an instructor or SPC. You'll then wait to be released by your company and remain in a duty status until all students have returned from the training area. So now that you have a better understanding of what these events look like, let's talk about the equipment that's required. So within your map kits, you should have 2 maps. One is a 1 in 50,000 scale map, the other is a 1 in 25,000 scale map. Since land navigation is a progression at the basic school, you'll start your events with a 1 in 25,000 map, which applies to your practical application, Land Nav 1, Land Nav 1 Night, and Final Land Nav Night. For the remaining events, you'll transition to the 1 in 50,000 scale map. Listed on the screen are each of the training areas that you'll be operating in throughout the Land Nav package. Of course, you'll be required to have your military issue compass, a protractor, which I recommend the Ranger Joe protractor for the most accuracy, a straight edge in order to draw your azimuth, which we'll be discussing in a later class, a whistle for safety purposes, map pens for map work. Again, recommend the Stedler Lumicolor 0.4mm for the most accuracy. It should have an S on the top of the lid for super fine. And the remaining items in your map kit either apply to your ability to effectively conduct map work out in the tree line or for safety purposes. Now here's a quick breakdown of some rules and restrictions that apply. Now some of these seem very intuitive, but again, we briefed these for a reason. So no riding in POVs or hitchhiking by any means throughout the conduct of any of your land navigation events. No GPS or GPS-enabled devices are allowed at any of the land nav events, to include your cell phone or any GPS-enabled watches. If you're required to bring these items as a billet holder, I can collect those items after the safety brief and then return those items safely to you post-execution. Now keep in mind, after the prac app, each one of your independent practical applications are individual effort events, so no talking or collaborating with other students is required. If you do need to ask a question, find a staff member or an instructor. Now TA-16 is the training area where your final land nav day will be conducted. So you are not authorized to enter TA-16 unless escorted prior to that event. Now, since you'll be utilizing 2 different scale maps, you'll be required to utilize the proper scale map for the event as designated. And finally, make sure you're staying out of impact areas, which should be marked with signage such as this. Last, no cheating is authorized for land navigation at the basic school. You may have seen this Marine Corps Times cover. Don't let that be you. Apply the techniques that we teach you, and you should have no issues conducting land nav. Now remember, land nav is a PT event. You'll be operating in the tree line upwards of 7 hours for a single event. This will be required for you to traverse significant distances in difficult terrain. Now, mental and physical toughness is key. Small victories based off the utilization of good techniques that we teach you will ultimately help you create momentum in the tree line. So now that you have a better understanding of land navigation at the basic school, let's dive into the actual content for this class, which is Military Topographic Maps 1. For the remainder of this class, I'll discuss the information provided in the margins of your map, provide an introduction to contour lines, and discuss the colors and topographic symbols represented on the content of your maps. The latter half of the class will cover the military grid reference system, plotting points, and determining distances. Now, there are some practical application portions of this class, so on hand you should have your laminated 1 in 50,000 scale and 1 in 25,000 scale maps, your protractor, straight edge, and map pens. When discussing the marginal information on your maps, it's important to note that the purpose of that information is threefold. First, identification in terms of locating the geographic or political region represented on the map. Interpretation in terms of interpreting the topographic symbols, colors, and contour lines represented on the map. And evaluation, which speaks to the relevance of the map's content based on the date it was produced and the accuracy of the source. In reviewing the marginal information on your 1 in 50,000 scale Quantico LandNav special maps, we'll start with the series name and scale. The series name of a map generally refers to the most prominent geographical or political region represented on the map, in our case, the state of Virginia. Adjacent to the series name is the map's scale. On this map, 1 unit of measure on the map equals 50,000 units in the real world. Next, we'll discuss how maps are categorized based on scale and size. Small-scale maps are generally used for planning purposes on the strategic level. They cover the largest area of land but depict the least amount of detail in terrain. Small-scale maps are categorized as 1 in 1 million scale and smaller. If you look at the map bit on the screen, I've circled Marine Corps Air Station Quantico in red. As we look at larger scale maps, we'll see how the scale impacts the actual representation of this same feature. Medium scale maps fall within the range of 1 in 75,000 and 1 in 1 million. They are generally used on the operational level and for air operations. Circled again is Marine Corps Air Station Quantico, represented on a 1 in 50,000, 1 in 500,000 scale map. Finally, large-scale maps are categorized as 1 in 75,000 scale and larger. These are used on the tactical level and are the types of maps that you will utilize for LandNav at the basic school. The last depiction of Marine Corps Air Station Quantico is represented on a 1 in 50,000 scale map, which is the map that you should have in front of you. Note the difference in the level of terrain and the level of detail in that terrain between your 1 in 25,000 scale map and your 1 in 50,000 scale map. The more detailed terrain on the 1 in 25,000 scale map can be used for tactical purposes such as identifying key terrain to establish a defensive battle position, while the 1 in 50,000 scale map is generally more user-friendly when planning operations in a larger area of operations. Now let's continue reviewing the marginal information on your 1 in 50,000 scale map. The series number of the map is depicted in the top right portion of your margins. The series number, generally represented by an alphanumeric code, informs you which area is represented within the larger series. A series name contains multiple series numbers. Now, the sheet name of the map further specifies the area represented on the map. In our case, is defined by Quantico, or its full name, the Quantico Military Installations Map, LandNav Special. Now, if you look at the adjoining sheets diagram, you can see how your specific sheet aligns with other sheets within the same series. We'll see how this is important later when we talk about horizontal and vertical datum. Now, looking at the index to boundaries diagram, you can identify the geopolitical boundaries depicted on your map. In our case, these boundaries represent county lines. To dive a little bit deeper on the topic of boundaries, see if you can identify the country depicted on this map. If geography is not your best subject, this is actually the country of Georgia depicted by a US-produced map. Now, this is also a map of Georgia, but is represented on a locally produced map. The key difference is the delineation of local boundaries. The country is further divided on the locally produced map by boundaries that are not necessarily recognized by the US. This is important to note because when operating in another country, supplementing US-produced maps with locally produced maps may provide valuable information regarding local geopolitical divisions. Next is the elevation guide. This provides you with general elevation trends across the entirety of your map. In the case of the Quantico Land Nav Special, you can identify a low-lying area to the northwest and continuing in a southeast direction, recognize an increase in elevation and subsequent decrease approaching the water feature. Next is the declination diagram. You receive more information regarding the declination diagram and how to utilize it in the following class on direction, but this tool ultimately helps you determine the deviation between true north, magnetic north, and grid north in the region depicted on the map. The most valuable information on the declination diagram for land nav purposes is the GM angle. This angle represents the conversion between grid north and magnetic north, which shifts over time due to shifts in the Earth's magnetic fields. The current GM angle for Quantico is 11 degrees west. If either of your maps indicate a different GM angle, cross it out and write in 11. Now the bar scale on your maps is used to measure the distance between 2 points. Pretty straightforward. The bar scale on your map should include 3 separate units of measure, including kilometers, nautical miles, and statute miles. For the purpose of land navigation, you will utilize the kilometer scale. I'll discuss how to utilize this scale later in the class. Next, identify the informational table in your margins, which indicates the contour interval note, as well as the vertical and horizontal datum. Now, the contour interval note, which will be discussed more in depth in military topographic maps 2, indicates the change in elevation between contour lines. In our case, this is 10 meters. Now, regarding datum, horizontal datum is the most applicable for land navigation. Horizontal datum informs the accuracy of the map's grid lines. When utilizing maps from adjoining sheets, the horizontal datum must match in order to properly align the grid squares. Vertical datum is more applicable to air operations and informs terrain elevation. Now, to further emphasize this note on horizontal datum, the maps on the slide were produced from 2 separate sets of horizontal datum. Now, as a result, the same point plotted on both maps expresses a deviation of 200 meters. Note, the map on the right is 32 years older than the map on the left. This is likely the cause for the deviation in the horizontal datum. Now, looking at the barcode portion of your marginal information, you can identify the national stock number and NGA reference number, both used for tracking and procurement purposes. Above the barcode, you will also see an indicator as to which colored lens this map can be read under. This is valuable information when operating in a night environment. Finally, the legend of your map defines the topographic symbols represented in the content of your map. For example, you can identify road types, bridges, water features, and type of vegetation, all based on the information provided in the legend. Interpretation of the legend will be discussed more in depth during military topographic maps 2. Now, map developers strive to create the most realistic representation of real-world terrain with topographic symbols. For example, Mainside Quantico is depicted with a significant level of detail in its corresponding topographic symbol. So now that you have a better understanding of how to read and interpret your marginal information, let's review the colors represented in the content of your map. Now, black features represent man-made features, to include buildings and any other man-made structures. It's important to note that any buildings less than 25 square meters on your 1 in 50,000 scale map are simply represented by a dot. Brown features represent terrain features or contour lines. These depict changes in elevation based off the contour interval note. Again, we'll dive more in depth on the topic of contour lines in military topographic maps too. Green represents areas of vegetation, which are ultimately delineated by type of vegetation according to the legend. Blue features naturally represent water features, again with the type of water feature informed by the legend and the topographic symbol. Finally, urban areas are shown represented in red, brown, or gray coloring. Now, map developers transitioned to gray in 1982 in order to amplify red lens readability at night. Your map should be depicted with a gray coloring for all urban and cultural areas. Now that concludes the first half of the class, where we discussed the purpose and conduct of land navigation at the basic school and introduced you to the marginal information on your maps. Now the next portion of the class will focus mainly on the military grid reference system. Now, in order to introduce the military grid reference system, see if you can identify the location of the building in the photo. Now, hopefully, if you're a good American, you're able to identify this building as the White House, located at 1600 Pennsylvania Ave. Now, the question is not meant to insult your intelligence, but is meant to emphasize how easily we can identify a location that exists at a well-known street address. Now, how do we identify a location that doesn't necessarily have a street address associated with it? For example, how do we identify the location of this defensive battle position? Or this lieutenant walking around looking for his rifle? Or even this lieutenant racked out while he's supposed to be holding security? Now, the value of the military grid reference system is that it helps us identify any location on the surface of the Earth to the nearest meter, whether it's a populated urban area or a fighting hole in the middle of the Quantico Highlands. Now, here's a look at how we'll break down these concepts in the class. So first, we'll discuss the origins of the military grid reference system and the two systems that it's derived from. We'll then talk about how to actually determine a grid coordinate, plot that grid coordinate with your protractor, and then taking two of those plotted points, determine the distance between them. Now, by definition, the military grid reference system is a geocoordinate standard used by NATO militaries for locating points on the Earth. It's important to note that the military grid reference system is derived from two separate grid systems, which include the Universal Transverse Mercator as well as the Universal Polar Stereographic. The MGRS combines naming conventions from both systems in order to mitigate the redundancy of grid coordinates. In more simple terms, without the naming conventions offered by the MGRS, a single grid coordinate can be represented by multiple points around the world. Now let's break this down further by looking at each subsystem. Starting with the Universal Transverse Mercator, or UTM, this system divides the Earth, or the surface of the Earth, excluding the North and South Pole, into 60 longitudinal belts, labeled numerically, as well as 20 latitudinal belts, labeled alphabetically. Now, the Universal Polar Stereographic, or UPS, then fills in the gaps with the North and South Pole, labeled respectively in semicircles, with Yankee Zulu at the north and Alpha Bravo at the south. Now, the MGRS combines the alphanumeric codes provided by both the UTM and UPS with a grid coordinate to identify a unique point on the surface of the Earth. The subdivisions of the UTM and UPS are referred to as grid zone designators. Now, as depicted on this slide, Quantico lies within the 18 Sierra grid zone designator. Now, looking at the 18 Sierra grid zone designator, this is further broken down into 100,000 square meter grid square identifiers. These are labeled with 2-letter codes. Quantico falls between the Tango Hotel and Uniform Hotel grid square identifiers. Now let's review the breakdown of a military grid reference system grid coordinate. From big to small, the grid begins with the grid zone designator, then the grid square identifier, and finally the actual 2 to 10-digit grid coordinate. Now, a 2-digit grid is going to specify 10,000 meters in accuracy, and a 10-digit grid is going to specify accuracy to 1 meter. Now here's a depiction of your Quantico LandNav Special map. Now, as mentioned, the map falls between the Tango Hotel as well as the Uniform Hotel grid square identifiers divided by the 00 vertical grid line. Now, this information is also provided in your margins in the grid reference box. Now let's discuss how to identify an actual individual grid square on your maps. Keep in mind each grid square is 1,000 square meters. Now, when annotating a grid square, always move from left to right and bottom up. For example, the leftmost grid line on this square is 12, and the bottommost grid line on this square is 45. Therefore, we're looking at the 1, 2, 4, 5 grid square. Now, take some time to identify the grid square of the FBI buildings on both your 1 in 50,000 scale and 1 in 25,000 scale maps. You should have identified the FBI buildings in both the 8667 and 8666 grid squares. Now, in order to determine a grid coordinate with greater accuracy than a 4-digit grid, you will need to utilize your protractor. Your protractor should have 3 separate scales cut out of the plastic. Each scale is meant for use with the corresponding scale of your map. Next, I'll show you how to determine a 6-digit grid coordinate for a point on your maps. Keep in mind, a 6-digit grid offers accuracy up to 100 meters. Now, we're first going to start with our grid square. Again, if we're going to move from left to right and bottom up, we'll then identify that our grid square is 8664. Now, once we have a point plotted within the 8664 grid square, we'll then take the vertical portion of our protractor scale and align it with the leftmost vertical grid square grid line, ensuring that the bottom portion of our scale is aligned with the bottommost horizontal grid line of our grid square. Once aligned, you'll then slide your protractor scale until it intersects with the actual point on the vertical scale. Next, you'll look at where the leftmost vertical grid square line intersects with the scale on your protractor horizontally. In our case, we see that horizontal intersection is going to be at the 700 meter tick mark, whereas that vertical intersection with our plotted point is at the 600 meter tick mark. We then know that our 6-digit grid for the point plotted within our grid square is 867646. Now, utilizing that technique, take some time to identify the 6-digit grid for LZ7 on both of your maps. Practice utilizing the different scales on your protractor as they correspond to your 1 in 50,000 scale and 1 in 25,000 scale maps. You should have identified LZ7 at Tango Hotel 867641. Now remember to always include the grid square identifier up front. Now do the same for the following 2 locations listed on the slide. You should have identified the Neebsco School at Tango Hotel 967778 and the Ripon School at Uniform Hotel 026773. Now, let's continue to refine our accuracy with an 8-digit grid, which gives us an accuracy of 10 meters. This is the type of grid you will receive for land nav purposes. Now the same process applies. Once you have identified your grid square and have a point plotted within that grid square, you then align your protractor properly, slide the protractor to the right until the verticalmost scale on your protractor intersects with the actual point. You'll then identify first where the leftmost grid line intersects with your protractor scale. And then identify where your vertical scale intersects with the actual plotted point. In our case, that horizontal scale intersects at the 7-4 tick mark, whereas our vertical scale intersects at the 6-3 tick mark, creating our full 8-digit grid of 86746463. Now, in order to practice determining an 8-digit grid, find the 8-digit grid coordinate for the following: intersection of Muddy Road and Service Road 617 and grid square Tango Hotel 8272. Now looking at that point, utilizing the technique, you should have determined that 8-digit grid is Tango Hotel 8216 7268. Next, I'll discuss how to determine the distance between two plotted points. Now, if the distance between 2 points is greater than the scale represented on your protractor, you will be required to utilize this technique. First, cut out a rectangular piece of paper long enough to span the distance between the 2 points. Then, make a tick mark above each of those points. Finally, utilize the bar scale in your margins to determine the distance. This is accomplished by aligning the rightmost tick mark to the nearest 1,000 meters, then utilizing the overhang on the left side to determine the accuracy to the nearest 100 meters. In our case, the total distance is 3,200 meters. In order to practice, utilize your 50,000 scale map, your 1 in 50,000 scale map, to plot the listed points and determine the distance between them. Here's a look at those two plotted points. Now, utilizing that technique, you should have determined that that distance is approximately 3,400 meters. Now, for testing purposes, we'll provide you with a tolerance of up to 30 meters. Now, when measuring a straight line distance, this does not always account for changes in elevation. Looking at the image depicted from the ground, we see that there is a significant terrain feature between the 2 points. This may require taking a nonlinear path to reach the endpoint. Now, this can be accomplished by breaking down the nonlinear path into linear segments. Then utilize your rectangular sheet to draw tick marks on your paper above each segment. Then taking the accumulation of those segments and utilizing your bar scale to gain the total. Now, this concludes Military Topographic Maps 1. Here's a quick summary of the topics discussed. Keep in mind these concepts build on each other for the duration of the land navigation platform instruction. If you have any further questions regarding the content of this class, please contact myself or another land navigation primary instructor via email or by linking up in the bullpen. Remember, as a Marine Corps officer and leader, it is your responsibility to retain the land navigation skills you acquire at the basic school, train your Marines to the same standard, and apply those skills with confidence when the time comes.